Hello everyone, very good morning. Today our topic is a transient response. That is, we are going to see the derivation of DC response of Rlcd circuit. Here we have the pictorial representation of Rlcd circuit, which consists of voltage source, switch, resistor and inductor. All are connected in series. Here we are going to see the response when switch is closed and when switch is open. When switch is open, there is no current flowing, so therefore there is no response. So when switch is closed, the current starts flowing in the resistor but not in the inductor. That is, at the instant when switch is closed, the current in the inductor is 0, because when switch is closed for a long time, then only the current starts flowing in the inductor. So at the instant when switch is closed, the current in the inductor is 0. So here, when switch is open, the initial current in the inductor is taken as I of 0 minus, that is equal to 0, and when switch is closed, the initial current in the inductor is taken as I of 0 plus is equal to 0. So in both the condition, the current in the inductor is taken as 0, that is initial current in the inductor is taken as 0, and this is the equivalent circuit of RL circuit when switch is closed at time t is equal to 0. So let us assume when the switch is closed at time t is equal to 0, so applying Kirchhoff's voltage law. So we all know what is Kirchhoff's voltage law. At any closed path, the summation of potential rise is equal to summation of potential drop in the circuit. The potential rise is V is equal to, the drops are R into I of t plus L into d by dt into I of t. So this is the differential equation which we obtained and taken as equation number 1. So taking Laplace transform on the differential equation on both the sides, we get Laplace of V by S is equal to Laplace of R into I of t, we get R into I of S, plus Laplace of L into d by dt into I of t, we get L into S into I of S minus I of 0 plus. So the I of 0 plus is the initial current in the inductor. So we all know that I of 0 plus is equal to 0 at the instant of switch is closing. So there is no current in the inductor. So therefore I of 0 plus is equal to 0. So we get V by S into R into I of S plus L into S into I of S. When I of 0 plus is equal to 0, we get this equation. So here in the right hand side, we are having I of S in the both the elements R and L. So we are taking the I of S is common. As we are taking the I of S as common, we get I of S into R plus L into S is equal to V by S. So our response of the circuit is current. So therefore taking the I of S left hand side, I of S is equal to V divided by S into R plus S into L. So our original input is in the form of t, and we are taking the response in the form of S. So we have to go back to the original input. So we need to take inverse Laplace transform. So we obtain the equations V divided by S into R plus S into L. So in this equation we cannot able to take inverse Laplace transform. We need to get in the form of S plus A formation. So that what we are going to do is, we are going to take L outside. So I of S is equal to V divided by S into L into R by L plus S. This is equation number 2. and L goes to the numerator. So by partial fraction method, by applying partial fraction method, so we are taking the first as A and second term as B. So V by L divided by S into S plus RL is equal to the first term we are taking A by S plus the second term we are representing B divided by S plus R divided by L. This is the third equation. So by cross multiplying the A into S plus R by L plus B S, we get the following equation: V by L divided by S into S plus RL is equal to A divided by S plus RL plus BS divided by S into S plus RL. So in both the sides we are having the term S into S plus RL. So by cancelling that, we get the following equation: V by L is equal to A into S plus RL plus BS. So substituting S is equal to 0, we get the following equation: V by L is equal to A into R plus L, because in the B term only S term is there, so when substituting 0, the B term will get cancelled, and we are getting the equation V by L is equal to A by A into R divided by L when S is taken as 0. So therefore the A value, A is equal to V by L divided by R by L is equal to V by R. So we get the A value as V by R. So A is equal to V by R. Second is substituting S is equal to minus R by L. So V by L is equal to A into S. S becomes minus R by L plus R by L plus B into S, that is S comes as minus R by L. So in A term we have minus R by L plus R by L. So both the term will become 0. So A term will become as 0. So therefore we get V by L is equal to minus B into R by L. So taking B is equal to minus V by R. So substituting the value of A value and B value in the third equation, we get IFS is equal to V by R divided by S minus V by R divided by S plus R into R divided by L. So here we have in both the term V by R as common in the numerator term. So IFS is equal to V by R into 1 by S minus 1 by S plus R. So you could see here, so we got the function as taking the inverse Laplace function, inverse Laplace transform, that is 1 by S and 1 by S plus A. So these terms seems to be 1 by S, and the second term seems to be 1 by S plus A formation. So when we are taking inverse Laplace on 1 by S, we get 1, and when we are taking inverse Laplace of 1 by S plus A, we get e power minus at. So taking inverse Laplace transform on the above equation, the inverse Laplace transform of IFS will become I of t is equal to V by R, and inverse Laplace of 1 by S is we will get as 1 minus inverse Laplace of 1 by S plus R divided by L, we get e power of minus R divided by L into t, that is S plus A. Here we have R by L, so therefore e power minus R divided by L into t. This is the equation number 4 we got. So as you all know, the time constant is the ratio between the inductor and the resistor, which is represented as capital T. So where time constant T is equal to L divided by R. So substituting that, I of t is equal to V by R into 1 minus e power minus t divided by the L by R will become as capital T. So that is represented as equation number 5. So we know by Ohm's law I is equal to V by R. Substituting there, I of t is equal to V by R will become I into 1 minus e power minus t divided by t. That is equation number 6. So substituting small t is equal to capital T in the above equation, we get I of t is equal to capital I into 1 minus e power minus t divided by t. That is e power minus 1 will become, that is capital T and capital T will get cancelled. So therefore I of t is equal to, when we substitute the value 1 minus e power minus 1, we get 0.632 into I. That is I is equal to 63.2% of current. So graphically we could see here the current reaches the steady state at 63.2% of its final value. Graphically we could see here the current and the time. Current is taken as y-axis and t is taken as x-axis. Thus, the time constant of Rlcd circuit is defined as time taken for the response to reach 63.2% of its final value. That is, the current is attaining the steady state at 63.2% of its final value. So when we are substituting the time, the t value is equal to 0t, is equal to 1t, is equal to 2t, is equal to 3t, or is equal to 4t, we get the current value. The current value will go on increasing, and in certain point it will attain the steady state. That could be at 60 or 5t. So that the current is attaining the steady state and it is reaching the final value of 63.2% of current. Thank you.